All right, good morning, everyone. If you're online, I do ask that you turn on your cameras. Let's get started with today's exercise. So, last class period, we retrieved data from DayMat, an open source database for daily weather variables across North America at a 1 by 1 kilometer grid spatial resolution. In class, we did have, so let me just pull up my script here, just to remind you, we did do the pulling data just for the first 5 side years, if you remember, when we did in this code right here, right? I did ask you that after class, when you went back to your offices, that you basically commented off that slice or just deleted that, so you would be able to pull data for all 698 side years. I'm assuming that you did that and that you also exported that at the end right here. So you actually have this fieldweatherdata.csv on file that has weather data from DayMat for all 698 side years. That was something I asked you to do outside of class because it may take you a moment to download all 698 side years worth of weather data. So my assumption is that you have done that as we move forward with our next exercise. So today's exercise is going to be about feature engineering. I did just earlier today upload a partial script to 2024 DSA. I want to ask you to go and do a git pull on that. You're not going to have to create a new project. I just want you to get the new partial script and move or copy that script inside of the code folder of this current project, 09 Open Data. We're just going to add a new script to this project and work out of that. I will give you a moment here to do that. So again, no need to create new RStudio project or new subfolders. You're just going to copy the new script from 2024 DSA into the code folder of the current project, 09 Open Data. Anyone needing help with that? All right, so I'm going to get started here just because we have some introduction first. And by the time that we get to the coding part, if someone still needs to catch up, let me know. I can wait a moment here. All right, so feature engineering is this term that basically just means, I guess here we have one of the concepts of the practice of finding better representations of predictors, or in other words, features, to improve predictive performance is referred to as feature engineering. So another way of thinking of that is sometimes the variables that you have at hand may contain important information, but they may not be in the best format for you to really train a model with, right? So maybe you can derive secondary variables from them, or perhaps do some transformations to them, combine them in different ways. And all those steps are things that we refer to as feature engineering. You're engineering new features out of the current ones that you have with the goal of creating better representations of those features when it comes to training any model. And in our case, as we're going to start moving forward with this, with machine learning models. So with that, our learning objectives for this exercise are going to be to apply feature engineering concepts to the DayMat daily weather data that we retrieved last class. And then export these feature engineered data set so we can use down the pipeline as we start moving forward with more models and including machine learning models. All right, so this point is where we're going to start coding. I want to ask you to, I think we're just using the tidyverse packages today. So by that, I mean using dplyr and tidyr for data wrangling, using ggplot2 for plotting. It's going to be a very simple exercise when it comes to number of packages, but I'm going to be exposing you to a few different aspects of, I guess, overall data wrangling, but that is going to be very applicable here and very useful as well. So if you just want to go ahead and load or run the first chunk, so you load the tidyverse, and also just a quick, I guess, heads up here. We may have seen this before. I don't quite remember if I paid much attention to it or gave you much explanation about it. But in chunks, we have chunk options. And if you're using a Quarto file, you can either specify those options. So I could say message equals false, or you can specify those options here. So here I'm just changing the behavior of this chunk. So I'm asking it to not display any messages or warnings. So setting that to false. If you just use the hashtag pipe, well, I guess it's not giving me, if I hit tab, it's not giving me all the options, but there's a whole bunch of chunk options here. These are some of them, but if if for some reason you want to control the behavior of a chunk, you can just Google like Quarto chunk options. You're gonna have a list of them and what they do. So this is just what I'm doing here, is just inhibiting tidyverse from showing all those messages that it normally shows. Okay, so the first step here for us is going to be to bring in the data set that we exported from the previous script. If you recall, the reason, again, that we have a separate script basically for retrieving that weather data, separating that from the actual wrangling and afterwards analysis, is because I think that creating scripts that are very focused on a task are very helpful, especially as you develop your analysis and as they become more complex. In a way that a script has data coming in, does something to it, has data going out. And then that outgoing data is then used as the incoming data on the next script, and you just do that way a flow. That keeps your scripts a little bit shorter, also more focused on a given task. And I think overall is more helpful. And I do encourage you to do that for your own analysis. So here we're basically having the second script of this series here, where now we're going to bring the DMAT data and then create some new features out of that. So let's go ahead and bring in the data. We give it the assignment symbol. We're going to use read_CSV because we did export that as a CSV file. If you open and close quotation marks, we get outside of the code folder by .. If you hit tab, go inside of the data folder, which is where we exported the data set from the previous scripts. And that one should be called field weather data. At least that's how I named on my side when I exported. I think you also did that. So if you run that, and we just print it here to quickly explore it, you should all have 254,000 rows in this data set. That would be the correct number of rows if you're able to pull weather data from all of those 678 site years. You should have this amount of rows. And then we have 19 columns, right? So we have the original ones that we started with. So before we got DMAT data, which were year, site, lat, long, and strength. And then we have all the variables that came through from the DMAT call. So site 2, tile, latitude, longitude again, altitude, year 2, just because it has that variable in there as well. And then Y day, if you remember, Y day ranges from 1 to 365 because we have daily data for each one of the site years. So we have this weather data in this way. And then all the weather variables, day length, precipitation, solar radiation, snow, water equivalent, Tmax, Tmin, and vapor pressure. All right, so again, the reason why we have this number of rows is because we had 698 site years And for each one of those light years, we have 365 rows or 365 days within each one of those light years. So if you multiply those two, you get that number of rows. That's why we have those many number of rows. All right, so as always, let's do some EDA. So here we're gonna check first the summary. So we're gonna get the summary here of all these variables. You know, so I guess we kind of, I don't remember now if we took a look at this, but you know, maybe a few things to notice here. So I always use summary just to get an idea if we're getting, you know, negative values where there shouldn't be negative values or things of that extent. So here we're seeing precipitation ranging from 0. The median is 0, right? So if you think about it, precipitation is a very different variable because most of the time it is 0, right? If you're thinking on a daily basis, most of the time, at least I guess, you know, not everywhere potentially, but at least in the places that I lived, most of the time it does not rain every day. So we have a lot of zeros. The median of the data set is 0, but we have this maximum here of 230 millimeters per day that happen once somewhere, right? So a lot of water in that one day, but it's a variable that we have a lot of zeros in that. So just for us to keep that in our heads as well. Solar radiation, we see here as well. It makes sense, the range of values, snow water equivalent. I guess it makes sense as well. It will be kind of similar to some extent of the behavior of what rainfall is. It's just rainfall in the snow format. And then we have Tmax and Tmin. So here is where, you know, we look at the minimums here, we see negative values. This is yearly weather data. And as we already saw, this is for the southern US states. So it makes sense that your Tmax, but especially your Tmin, your minimum temperature of a given day is below 0. So that would be okay to have negative values, right? We would expect that to happen. So just for us to kind of do a quick check on that. And then vapor pressure is still also within a range of possible values. All right, so we just saw this very quick statistical summary of these numerical variables. I always like to visualize things. I think plots are a lot better for us to get an understanding of what's going on with these variables. So I want to go ahead in the next step on this EDA workflow, just to create some density plots for each one of the weather variables. So let's go ahead and do that. Let's start with that object. So that is field weather. I just want to print that below so we take again another look at it. So my goal here is to create density plots. So if you remember, density plots are kind of like histograms, just the outline of a histogram. And I want to do that for all the weather variables. So starting on day length and then going to VPPA, vapor pressure. So for us to do that, we've done this a couple times already. What would be the immediate next step here for us to be able to do that in ggplot in an easy way? Say that again. So geom density is what we're going to use, but before we get to ggplot, we need to do something with this data set to make that process a little bit easier. Yes, I heard pivot longer. That's exactly it, right? Because we want a column that has all the titles of these current weather variables. Pivot longer, yes. Yes, that's exactly right, Sekar. So Sekar is saying pivot longer in geom density with faster rep. That's exactly it, right? So before we get to ggplot, we have to pivot longer here. And this is something that, you know, you're going to see a lot, that sometimes you can change something in the plot itself, but sometimes that change has to happen in the data set level before it even gets to ggplot. This is one of those examples. So let's go ahead and do a pivot longer here. So what I want to say is, so it has this argument for cols, and because our weather variables are consecutive in sequence, we can just say starting on day L_S, give it a colon, and then ending on VP_PA. If we do that, now we have 1,000,000, almost 800,000 rows, because now we took all those weather variables that were in a wide format and we stacked them in a long format. And now we have two new columns, right? So we have name, which now has all the previous weather variable names, and the column value that now has all the previous values. All right, so now we're ready to get into ggplot. So let's just add a pipe called ggplot. Right here, we can say AES and determine our axis. If you recall, if we know we're doing geom density, remember that geom density only needs an x-axis value, and that is going to be x equals to value, right? So we want this column here. We do not need to provide a y-axis variable because that's going to be calculated by geom density for us. So now, if we just follow that up with a geom underscore density, if we just run this, it's going to be one huge geom density that is going to be very useless because it has data across all those other variables mixed in one density, which does not make sense to compare something that ranges from 0 to 200 to something that varies from 0 to 4,000, or I guess 50,000 here we have. So let's go ahead then and facet this, right? So we add a plus. Let's use a facet wrap. We can say dot tilde name. If you remember, oops, name is the name of the column that has all the weather variable names. So we want to create one facet, one panel, one plot for each one of those weather variables. And then, well, if we just run this, we can go ahead and do that. This is what it's going to look like. So it's still not very useful. And here's why. If you look on the x-axis here, even though on my side at least it's kind of crammed, so it's difficult to see, but all the x-axis and actually the y-axis as well, values are set to be the same across all of those facets. That is the default behavior of facet wrap. We can tell facet wrap to allow the x-axis range of values to change. We can tell it to allow just the y-axis values to change between facets, or we can tell it to allow both x and y to change. So we can come here on facet wrap. It has this argument for scales. If I want to allow both x and y to change, I just say free. If I wanted to allow only x or only y, I would say free underscore x or free underscore y. In our case here, I do want to allow both of them to vary. So if you do that, then now facet wrap adjusts both the y-axis and the x-axis ranges to match each one of the variables individually. So if we just take a quick look here, kind of interesting to see that on day length, we have kind of like two modes, two like peaks, one at the beginning and one at the end of that distribution. Yeah, I guess it's just a feature of the data, but it's interesting to see that that's how it is. Precipitation, again, we see this very high peak at 0 because, again, this is at a daily scale. So with that, we do have a lot of zeros in this data set, but then we do have very long tails, right? Meaning that we have outliers, which in this case here does not mean a wrong data point necessarily. It just means that there are very extreme cases, but the majority of the points are near 0. Then solar radiation perhaps is the one that looks the most normal. Soil or snow water equivalent is kind of similar to precipitation. Then Tmax, we also see this peak here, probably around 30. Tmin is a little bit more almost like bimodal as well. We have a hump here and then we have a peak. And then vapor pressure also more centered towards the left, but has a longer tail as well. So this is always useful for us to look into and kind of have a feeling for how our variables are distributed. In this case here, that was just mostly for us to understand their behavior. But this may be a way that you can catch some errors in your data as well, especially if you have, so right now, going into this ggplot, we have almost 2 million rows of data, right? So it's really difficult to make sense of 2 million rows of data if you're just looking at numbers. Okay, so here's going to be a very important point about why we're doing what we're doing, and I want you to think along with me here. So I want to again just print field weather for us to look at that. Again, the 254,000 rows. So right now, this data is on a daily scale, right? On a daily time interval for all these weather variables, for all these side years. So this is a very good temporal scale to have our data in, especially for weather data. However, if you think about it, if we train a model with data on a daily scale, I think there's going to be a lot of noise there. And that's because imagine that we're going to say on March 28th of every single year, something happened that impacted yield. That is very unlikely, right? It's very unlikely that one given day had such a large impact every year in many different sites on any crop output. So weather on a daily scale is a little bit too fine, too detailed, right? For us to really relate with plant outputs. The exception there is probably, I mean, there's still going to be a lot of variability there, but normally plants would respond to the cumulative effects of weather, right? So it's not a single day that's going to make a huge difference. It's the cumulative effect of, let's say, precipitation or solar radiation or things like, or temperature and things like that. Unless perhaps if you have a very severe event, right? So if you have a flooding that wipes your field, or if you have a tornado that harvests the crop for you before you get there, those are cases that one day is going to make a huge difference, but those are still very erratic. It's not going to happen every single day, every year, everywhere, right? So for us to really be able to use this data in a more direct way that could be more directly related to a crop output, in our case here is cotton fiber quality, we need to engineer some features out of it. And so my question for you to think about before we get into a quiz is, how could we use this understanding that daily data is too fine? How can we engineer features out of this daily data to create new features that perhaps are going to be more related and less noisy when it comes to how plants respond to weather? So if you go to your ELC, I have a quiz there for you. Let me make it visible. All right, so I think now it should be visible. It's called quiz 4. It's just a question. You're not going to get a grade. At least I don't think you will get a grade after responding because it's really open-ended. I'm going to look into your answers afterwards and grade them myself. So if you do get a grade after that, don't worry. It's probably something related to ELC that I didn't set up properly. But I'll give you here just, 4 minutes just for you to think about and just write me a sentence of what you think, how you could change this, or how you would feature engineer out of daily data. All right, so the 4 minutes are done. Please make sure you submit it. There's really no right or wrong answer here. I'm just trying to get, trying to help you think through how we could get to, engineer some features out of daily data. So don't worry. As long as you, thought about it and gave me an answer that makes sense, there's no right or wrong answer. All right, so I was just checking some of the responses here, and so really I guess if we speak about feature engineering in a larger sense, there are different techniques and different ways of doing feature engineering. In this case, specifically here for weather, I want to talk about two components that we can vary here, and the answers that I saw were talking about some of these components. So you're all thinking about these already. So basically, we can use a summarizing time window size, and also a summarizing function that we want to apply to the window size. So first, talking a little bit more about the window size itself. So we could decide to aggregate this daily weather data in any temporal scale that makes sense. Perhaps weekly. I think weekly is still probably a little bit too granular for weather and impact on crops. But, we could do weekly, we could do monthly, every 2 months, perhaps for the whole growing season. For that, we have to either know planting and harvest dates, or you have to assume a planting and harvest date to define your growing season window, but we could do that. Also, if you do have more data on crop growth stages, or if you use some type of model like a growing degree days type of model to associate temperature with growing degree days, and then growing degree days with crop growth stages, you can also do that based on crop growth stages, right? So there's a lot of different windows of time that we can define here, and maybe even others, right? Perhaps there are other things, other types of windows of time that would make more sense to your application. So perhaps, I work with nitrogen a lot. So with nitrogen, it's really important the weather that is like right after, perhaps a week to 10 days, right after fertilizer application, as far as if you understand, what type of loss potential it may have that's related to weather. So maybe that would be a window that would be of interest for me. And then, you can think about different windows of time that may be important in your specific cases. So we first define the size of that window that we want to work with, and then we have to have that variable in our data set. And then we can define what function I want to apply to that window, right? So let's say that, I can apply some of the most common ones would be getting the mean of the values of weather within a given window, the median. Sometimes the minimum is the most important one. So I'm working with Dr. Lisa Baxter, who works with forages, and one of the questions that we have is that the daily minimum temperature is changing differently from South Georgia to North Georgia, and that impacts forage distribution. And so we pull some DayMat data to look at that. And indeed, if you look at the minimum, so we take we're already looking at that Tmin, so that is the variable, right? So it's the minimum temperature on a daily scale. But then you have that, let's say, for a whole month, and then extract the minimum of the Tmin during that period, right? So if we look at that plot and we plot for all months for a place in South Georgia, a place in North Georgia, we do see that since 1980 to this date, the minimum temperature has been increasing at a steeper slope in South Georgia than in North Georgia. So sometimes you may not be interested necessarily in the mean or the median. It may be the minimum. If you're looking at the other extreme would be the maximum, right? And then standard deviation, coefficient of variation, other statistical metrics you can get from that window that you are defining. So again, changing the window size based on some knowledge of time that relates to your crop, and also the summarizing function that you apply to that window size are two things that we can play around here and get new features out of this data. So for this exercise here, I want us to work on the following situation. I want to get a window size of monthly scale. So I want to aggregate data by month. And then I want to apply either the mean or the sum. And I was very inspired for this class, so I have yet another quiz for you to fill out. So if you go back to ELC, I'm gonna make that one visible for you. This is gonna be a like matching two columns. So please go ahead. I'm gonna give you here really 3 minutes because it's a very simple quiz. Can you see that? Yeah, so it's quiz 5. Okay, I think we're missing one person to answer this last one. So let's just go ahead, I guess. It was a pretty easy, straightforward one. All right, so I have now looked at your answers, and really, if you, I mean, I guess in this case, I wanted you to think of one or the other for the cases I gave you, but just to talk about it just in a little bit more, a little bit more depth, right? So let's say I say I want to get the mean of all variables within the window. We can do that. I guess that would make sense for most of those variables. I don't think it makes a lot of sense for precipitation though. And the reason for that is because we have so many zeros, right? So if you take the mean of precipitation, you're gonna have a very low value of that mean, and it's not really going to represent what the crop is seeing, right? Because the crop does not see the mean precipitation. It's actually the cumulative effect of precipitation over time. I guess you could argue that maybe temperature is also something that's important on a cumulative basis, or perhaps solar radiation. And I would agree with you. Perhaps temperature and solar radiation, maybe the mean and the cumulative could be important, to get both of those features out of those variables. But for precipitation specifically, I think that the mean makes no sense. I think that we should really look into, the cumulative precipitation within that period instead of getting the mean. All right, so moving forward here, I'm leaving you a couple of links. So we're going to be working with dates in R. If you ever work with dates in a programming language, you know that it can be very frustrating, it can be difficult to manage things. And I do want to provide you a couple of resources to do that more efficiently and easier in R. So one of them is this link here to an R bloggers, which is just a blog about R stuff. That it has a lot of stuff in that blog post, but really what I want to focus is just the date formats. So it has this table here for date formats that is, I a lot of times refer to either this or some other source of date formats to understand how my dates are currently and what I need to do to transform that character. Because a date, if you bring into R, may just be, as you import, if you already have, let's say, you already have a date column in your data set that you're importing to R, that's probably going to be imported as just a character. So like 2024, 03, 28. It is a very high value for us to make R understand that that is not just a character, but it's actually a date. And when we do that, when R actually treats that column as a date type of object or class of dates, then we can apply a lot of functions that really make life easy when you're working with dates in time. So these are some of the formats that we see, right? So some of the ones that I use a lot would be, so day of the month. If I have a column that has a day of the month, I would use percent lowercase d to tell R that that's what it is. If it has day of the year, it's going to be percent j. In our case, we're going to be using percent j because we have day of the year as one of our columns. If I have month as a number from 1 to 12, it's going to be percent lowercase m. If I want weekday, week number, so there are 53 weeks, I guess, in a year, we would use percent u and so on. So there's a lot of, you can take a look at this more closely if you wish. Another one that's very useful is percent uppercase y, which is year with 4 digits. You can also use percent lowercase y, which is year, just the last 2 digits. And there's a lot more here that you can look on your own if you need to, but I just wanted to show you this, that there is, depending how your dates are structured when you bring them in, you may need to tell R that this is a date and this is the format that date is in. So R understands how to interpret that date. All right, so if you come back to the script, so in our, so I guess I believe that these standards here of date formats that I just showed you, I think they are like standard, not just in R. But in R, there is a package that we can use to work with dates that is called LibreDate. If you ever need to work with dates, I would highly recommend you look into this package because it is very friendly and very useful. And there are other packages in R to work with dates, but I would suggest that you look into this one first. So it is a tidyverse package. So it is, from RStudio. They have a very nice cheat sheet that I just want to show you very quickly here that kind of summarizes a lot of the important functions in this package. So you can work with dates and times. There are different functions to extract different things out of dates and times. And you can do math with date time. So let's say if you have a starting point, let's say planting date and harvest date, you want to know how many days of growing season you had. You can do that math very easily using functions from this package. And anyways, there's a lot of things here about dates and times. So if you ever work with that, I would encourage you to look into this package. And now, so my goal here, so as I was telling you all, I want to extract the mean on a monthly basis for all of the site years, right? If we look in our data right now, I just want to print field weather here, just so we look at that. So I have year. And I have Y day, so day of the year, right? I do not have a full date, like I don't have a 2024-03-28. I don't have that. I do not have month, right? So those are things that if I do want to feature engineer based on month, I have to have a column that says month, and I do not have that yet. So our next step here is going to be to create that. So I left you some code here. So we're gonna everything we do in this chunk is gonna be assigned to this object called FE month. So feature engineering month. We're starting off with field weather, and I left you a dplyr select where I am selecting some of the columns. I'm leaving some others behind that we don't need, and I'm also renaming the style of all of the weather variables here. For right now, you can just I'm just renaming and selecting them. What I'm doing is just replacing the underscores with the dots. And if it has like too many underscores for the units, I'm just unifying that into one piece, not split by underscores. So here would be an example that we have watts per meter square. I think is that watts? Maybe. Anyways, W per meter square. I'm just consolidating that into one piece and not being split with two lowercase or underscore symbols there. I'm just making that change. If you just run this and if you print it, it's still gonna have the 254,000 rows. We have fewer columns now because we left we left tile behind and year 2, side 2, those columns. We still have strength, we have day of the year, and then all the weather variables renamed to what we did. The next step here that you're gonna help me with is to create a date class variable, right? So if we add a pipe here, I just wanna show you how we would do that in our case here. So the first thing I want to do is to create a column that is not going to be an actual date yet, but it's going to start looking like one. Somebody had a question here. Yeah, so Kriti, you're thinking ahead, and that's where we're going. So Kriti is saying here that we're going to use paste, year, and Y day, and that's correct. So let's actually, that is the immediate next step here, right? So if we come here and let's call it mutate. I want to call this column date underscore CHR. And I'm calling this CHR because it's still going to be a character type of column. And I do want us to differentiate that from the true date column that it's going to come after that. So as Kriti was saying, so we're going to use paste 0 as our function. So I want to combine here the year information. I do want to add a separator between the year and the day of the year. It could be anything, really. It doesn't have to be any specific symbol. I want to propose we use /, and then we call Y day. So what this is going to do is bring in the year value, put a slash after it, and then put the day of the year after that. If you just run this, and you print it, and you just browse to the last column here, this is how that looks like. So now we have year / day of the year, right? So this is gonna, for this first site year, that's gonna range from 1980 / 1 to 1980 / 365, right? So this one is not month, it is day of the year. Keep that in mind. All right, so now we have in one piece, in one column here, we have both the year and the day of the year information, which for R is gonna be enough for it to create a full date for us. So let's come here, give it a pipe. We're going to call another mutate. And this column here, I do want to call date. So that's going to be our actual date. We're going to use a function here to transform a character to a date that the function name is called s.date with uppercase D, where this function requires for us to tell first what is the current column that has the dates that we want to transform. That is the date underscore CHR. And then the second argument is what is the format of the current column, not the format you want it to be, but the format that the current column is as far as date format. So if we look at this, I just want to show you again. So if you remember, percent uppercase Y was year in 4 digits, and then percent lowercase j was day of the year. And then because we did provide here this /, we're going to have to incorporate that into the format as well. So the way that we're going to specify the format of this would be percent uppercase Y / percent lowercase j. Again, these formats I got from that table I was showing you the first thing. So if we run this, and now we print FE month, go all the way to the right, a couple of things to notice. Now it's providing us a full date that includes year, month, and day, which we did not have before. And also notice how this column here, the class of this column has changed to be a class date. It's not a character anymore like the date CHR is a date column. And that is powerful for us because now we can extract a whole bunch of different things from this current date column that we could not from the date CHR. So if you just browse through here, you're gonna, just flipping for some of the pages here. So notice how the second 01 here is remaining stable because that's the month, right? So 1980, January, and then the day of the month. So you're gonna see that after it gets after January 31st, then it flips to January 1st, right? So we transformed that. I was able to understand that to give you the information of month and day of the month based on day of the year, right? So this is very powerful. All right, so the next thing here is going to be really very simple. So now that this column is of type date, we can extract anything from it related to date. Let's give it a pipe. I want to come after that comment. We're going to ask another mutate. I want to call this new column as month. And on the package deliver date, there is a function called month. So we say month, and then we give the column that is an actual date column, which is name date in our case. So if you just do that, and now you print FE month, you're going to notice that you have a column at the end that says month, right? So now this is going from 1 to 12, where 1 is January, 12 is December. And just to show you here, if you skip past January, that flips to 2, just so we understand that that is actually working and doing what we would expect. And it is. All right. So another thing I want to do here, mostly for visualization purposes, is I do want to have the month, but instead of numerical, I wanted to have the abbreviation of the month name. So let's go ahead and give another pipe here. Let's call mutate again. I want to call this new column month underscore ABB for abbreviation. And this is basically going to be the same function that we called before. So month of date. And then it has an argument that is called label. If label equals to false, which is the default, then it gives you a number. If label equals to true, which is what we're changing now, then it gives you the shortened version of the month name rather than a number. So if you come here, now we have this column called month app that says January for when month is 1, February when month is 2, and so on. All right, so we basically now have a column with the month information, which is our summarizing window. If you would have used a different summarizing window, so let's say if you wanted to have on a weekly basis, or maybe, I don't know, on the growing season basis, this is where you would do that, right? This is where you would change your window here before you get to the actual summarizing function, which is what we're going to do on the next chunk. Yes.
Maybe a stupid question, but I think since we're going already, we don't have to worry about leap year or anything. We are actually the difference.
Yes, it's not, there's no stupid question. That was a great question. So Anis is asking here if you have a leap year, if that would be taken care of. And if you have the date, the column date being of type date, so the class of that column is date, then it would take care of that for you. You don't have to worry about it. Yep. Any other questions here? Yeah.
Getting any not available value there. Date and month and month date.
It happened to me. Maybe
So on date,
they don't put percentage sign properly. It happened to me.
yeah, so double check this part. You may be missing either a percent or the forward slash in between them. Anyone else having issues or maybe having questions? I'm just gonna give a moment here to. Let me come around.
Fine. Maybe go in, no question. They will, that is
But for what's that?
That's just like what you need to be.
Yeah. Then, thank you.
You buy the can, you go, I didn't really. Well, there's nothing like a dollar. Get like a packet.
No,
All right, so I think we're all caught up here, so let's go. So again, here I have a question. I was not detecting month function, I had to specify the package. Okay. Interesting, so Sekar is saying that R was not detecting the month function, and I guess my assumption was that LibraDate was part of Tidyverse. Did anyone have issues with running the month function? Okay. Yeah, I'm not sure, Sekar, I think no one else had that issue, but yeah, so again, this function month is coming from LibraDate, so if you were to have issues, you could just either explicitly load LibraDate, or something that Sekar did here, which we've been doing with some other cases, would be to just call the package name LibraDate followed by double colon signs there to force that function to come from that package. In datetime, which function works best while merging files? In datetime, which functions work best while merging files? Kriti, I feel like I would need some more background to help you with that question. But if that is something about your merging files based on datetime column. Okay, so let's say if you're merging, if you have, let's say if you do have weather data in one file, or in one data frame, and you have date and weather, and then on one data frame, and then on another data frame, you have date and let's say greenhouse gas emissions or something else, right? And you want to merge them, as long as the dates in both objects are under the same format, is just a left join. It's a very simple join. Yeah, if this is about something on your research, I can connect with you later as well and see and help you out there. But just as long as the columns have the same name and the same format for date, it should be a simple left join. All right, so we determine our window. So now we have a column for our window. Now let's apply our summarizing function here on the next gen. Let's begin here so we're going to assign that to this object called FE month sum. We're going to start off with the object that we just created above, which is FE_month. So that's where we determine the window, or we created the month column, which is our window. So for this, think about it this way. We want to extract the summarizing window per month, but if I just wait, let me take a step back here and ask you something rather than just tell you. All right, so our goal is to summarize weather for each month within each side year. What function do we need here? Group by, right? So we need group by here to create the group. We're going to do a group by. You're going to need to say year, site, and month. Right? If I just say month, you're going to end up with a data set that has 12 rows, because it's going to do the summarizing function for you across all the months without giving differentiation for year or site. We want months on a side year basis, so we do need to add that. Something that if you've been using these functions in the past, you may have realized that when you do a group by and summarize, all of the other variables that were not part of the group by and were not being summarized basically get dropped from the data set. which a lot of times that is what we want to do. But if you want to keep other variables that don't necessarily, are not going to necessarily impact the grouping, but you still want to have them after you summarize, what you can do is just add them in the group by anyways. So for example, I still wanted to keep the month abbreviation. So the month underscore ABB, and also the strength column, which is strength underscore GTEX. So these columns here are not here because I want to group by them, but just because I want them to carry along after we do the summarize. But we're really grouping by year, site, and month. All right, so you know, we created the grouping at this stage. Now we're going to apply a summarize. Here is the problem, I guess. Let me just print FE month for us to look at. So we have all of these weather variables that we want to summarize on a site, year, month basis. And some of them we want to apply the mean, and one of them we want to apply the sum. In the past, in dplyr, there used to be, I mean, there still is a function called summarize if, where you give a condition and you say, if the column is this, summarize this way. If the column is that, summarize that way. That function still exists and you may still be able to use it, but that approach is being superseded by the team that develops the package by another approach, which is called across. And I want to show you that approach because it's the newer approach. So you would be are going to learn what would be the most modern way of doing this in dplyr. So this function here is going to be called across. You can just call that function. So this function is going to take two arguments. Let's say an X and a Y argument. You don't have to type that. I just want to show you what those are. So X is going to be, you're going to find a way to tell this function which are the columns you want to do something with them. And then the Y here on this argument, Y is going to be the function that you want to apply to those columns. So the first thing I want to say here is I want to just give it all the weather variables that I want to take the mean of. So there are different ways of doing that, but on this X here, let's come here and give it a C function so we can concatenate column names. And we want to give all the column names that we want to take the mean of. So that would be, and the end does not have to be in quotation marks. So the first one was day L.S. While you're still inside the C function, you can break code to make it more readable. The second one is srad.wm2. As you start typing, it should pop up on your as a value for you to select. The next one is tmax.c. The next one is tmean.c. The last one is vp.pa. So I'm saying across these columns here that I'm just giving you the name, I want you to apply this function. So the function here is basically going to be mean, and it's just the name. It's not the mean function, so it does not have open and closing quotation marks. Let's see if this is going to work. So it did run, so did not get an error. Now notice that our total number of rows has decreased to 8,376 because this is because we're getting 698 site years times 12 months. That is this amount, this number here. If you come to the right, you're going to see that. So we still have the information of year, site, month, and month abbreviation, and also the strength, because those were all in our grouping variable or group by call. And then you have the same column names for what they were before, for day length, solar radiation, Tmax, and so on. But now these values here are the average of that month for that site and year. Right, so we basically took the average of all those columns by using a summarize. So it was the average because we call for the mean function. We use a summarize, and we use the across to say which columns we want to apply that function to. Another thing we can change here is it has an argument called dot names. So if you come after mean here, give it comma, there's an argument called dot names that you can give it a format of how you want your new columns to be called. Because these columns now, right now, they're just named as they were before, but I want their column names to say that they're actually the mean of those values, or not just the variable itself. So the way that we can say that is if you open and close quotation marks, I want to say the word mean, give it an underscore, and then we're going to use this notation here of curly brackets. You can open and close that, and then in between you just say .col. What happens here is that this first argument on the across, it is the .cols argument. So if we were to name that argument, it was .cols. So it knows that these are the columns, and this is the function I'm applying. I'm just giving that same function name here and using this placeholder that basically is going to be replaced by each one of the columns that I selected on the cols argument. So now if you run that and you print it, notice that now we have all of the weather variables are preceded by the word mean underscore, right? So we know what they are on this data set. All right, so we're going to basically do the same thing now, but for precipitation. And because we're applying two different functions to different columns, we can still be within this summarize. So if you come here before this, so if you come after the parentheses that closes across, so I see as I'm hovering across around this parentheses, it is highlighting that opening parentheses. So if you come after that, give it a comma and break code, we're going to give another across. So we're going to say across. The column is now just one, so it's prcp.mm for precipitation millimeters. The function now is going to be sum. That's the name of the function. And then the argument dot names, we can just change that to sum underscore, and then use the curly brackets and say .col. So notice how we're using two acrosses inside of one summarize, where the first one is selecting all the variables we want to apply the mean, applying the mean to them, and then renaming them to have the mean prefix, and then applying a second across that is just the precipitation column, because that one we do not want the mean, we want the sum of it. And then we're also giving this name that has sum as the prefix of it. So if you run that and you print it, now you should have those columns all with the mean preceding and then precipitation with the sum preceding. And then one last thing I want to do here is, if you notice when you print this object, it is a grouped object, right? So it has the groups here. This is needed and important when you're doing the summarize, but that structure remains in the object as you do other things to it. And sometimes the next steps of this workflow, we do not want those groups to be taken into account anymore, not that structure at least. So let's just go ahead and give it a pipe and call ungroup. So we remove that grouping behind the scenes so it doesn't affect anything we do afterwards. So now when you print it, you're going to see that it does not have the groups anymore. It's just a table, again, with 8,376 rows, where each one of those rows is a combination of a site, a year, and a month. And then we summarize the weather variables by those combinations. All right, so I left you here the code just for us to compare, to make sure. It's always good to check that, so the code is working, it's not giving us errors. But what if you made a mistake when you were coding, that the code still was able to run, but it's giving you a result that is not the correct one, right? So we always want to check what we're doing, especially when it's something like this, that, the result is applied to a whole bunch of different situations. We want to make sure that we have checks in place. So if I just look here for the first site in year, so first year is 1980, The site is Altus, Oklahoma. The month is the first month, so that is January. And then if we just look at two variables here, so let's look at Tmax and precip. Let me just decrease my. So the average Tmax for that first site year in January was 10 degrees Celsius, and the cumulative precipitation was 61 millimeters. I just left you the code here below, so you don't have to write anything, but I'm just starting with the object that we started on the beginning of the previous chunk, right? So before we did all the summarizing, I'm just starting with that object, which had like the 250 some rows, only filtering the first year, the first site, and the first month. So if you just print until here, it's going to be all the 31 days of January for the first year and first site, which is 1980 Altus, Oklahoma. And then I'm summarizing to get the mean Tmax and the sum of the precipitation, just for that, right? So we see that it is 10.17 Celsius, 61 millimeters, which matches what we're getting on our workflow above. So 61 millimeters, 10.17 Celsius, right? So just a check, just to make sure that it's doing what we intended for it to do. Okay, so, if we just look again at the latest data set we have, which is FE month sum. So we have the summarized variables. So we have 11 columns, right? Where I guess 1, 2, I think 7 or 6 here are weather related. And the month information is actually in a column. Now, most of the models we're going to be using are not going to be able to handle that, to understand that. So imagine that my goal here would be to run a model that's going to tell me, for example, that cumulative precipitation in August was the most important predictor of fiber or yield quality, of yield or fiber quality. So if that is what I'm looking for, if I want to know whatever weather variable I have here in a given period that I have, so in a given month, was the main predictor of something, I need to have a column. My columns need to have that month information in them, right? So right now, that month information is a column itself, which is if we train a model, it's not going to really be able to understand, that this January for a given variable is different from another January for another variable. So what I'm trying to get to is I wanted these columns to say mean day length of January, of February, of March, and so on. So we have a column for each combination of weather, summary, and month. Does that make sense? All right, so that's what we're going to do in the next step here. Just a sip of water. Okay, so if you come to the next chunk, we're going to start off with, we're going to assign that to this object, give it as the assignment symbol. We're going to start off with the object that we just developed above, which is called FE month sum, right? That is the one that we just developed. Now, there is probably a few different ways of doing this. So if you come across or if you develop yourself a different way, that is possible. As most things in programming languages, there's different ways of doing the same task. The way that I want to do this is going to be the following. So I'm just going to print FE month sum below here. I want to basically have a column that I have all the names of the current weather variables. And at that point, I can use a paste or paste 0 to combine the current name with the month abbreviation. Okay. So if I want to have a column with all the weather variable names, what function do I need here? So we need pivot longer, right? So let's go ahead and pivot longer again, where I basically, the columns here, so the argument calls is basically gonna be starting at mean day L dot S. Again, because the columns are consecutive, we can use this notation. So he's starting there and ending at some precip millimeters. That's what I want pivot longer, right? So if you run that and then you print, now we increase our number of rows to 50,000. Where I still have year, site, month abbreviation, strength is still there. But now we have a column for name that has all of the previous weather column headings and a column for value, which has all the previous values under those columns. Now it's really simple, right? So we just go ahead and add a pipe. We're gonna do a mutate. I want to call this next column here var name. It's arbitrary, I guess, but that's what I'm proposing that we name it. We're gonna use a pace 0 function, where the first argument here is gonna be, let's see what I had in my code. It's gonna be the name, so it's gonna be the variable name right here. So we do name, give it a comma. I want to give it a separator. And this is one of the places where the reason why I wanted to change the previous variable names to have a dot for the actual unit and not have a whole bunch of underscores, because I want to use the same separator here of underscore. So it's going to be the name, an underscore, and if you give comma, it's going to be then the month underscore ABB for month abbreviation. So if we run that and we print it, you go all the way to the right here. Now we have this column called var name that says mean day length in seconds in January. All right. However, this format is not the format that we're going to use to train a model, right? Because again, we have the issue here that all the column names are in a column and all the values are in one column as well. I wanted to throw it back to the way it was before. The only difference is that now those columns have the month information in them. How can we do that? Pivot wider, right? So pivot wider is the opposite of pivot longer. So we had it wide, we made it long, created a new column with the variable name and the month, and now we want to pivot wider again. So let's go ahead and call pivot wider. Here we're gonna say the two arguments it has is names from. So this is the current column that has the names. That column is called var name. And then he has a values from, and this is where we say where the values are, which currently are in a column called value. All right, if we do this and you print it, this is what happens. So this is a very common issue when you're pivoting the data. If you come across this, that you pivoted and you have a whole bunch of NAs where you should actually have data. So look at what's going on here. So the problem here is that we have other columns in this data frame that are not allowing this pivot to be a clean pivot. Because, for example, we have month and month abbreviation here, which I cannot pivot and have a whole bunch of, so let's say if I have a column that says February at some point, this first row is just January. So anything that's January, but the column says February is going to be an NA. So I have columns currently in my data frame that are not allowing for a clean pivot. If you see this when you do pivots, that is most likely the reason for that. The way to fix it is just to select out of the data frame those columns that are interfering with your pivots. So if you come here right before the pivot wider, let's do a dplyr select. The columns that are interfering there are both the name and the month abbreviation. So let's just say minus name, comma, minus month underscore ABB. Then don't forget to add a pipe after that. Now let's just go ahead and run it. So now I think it worked. Or not. No, it still didn't work. Oh, I think month is, yeah, we should also remove month, sorry. So let's come here and also do a minus month. Now I think that should work. Okay, that worked. So if we remove
Hey, quick
next,
question, Dr. Bastos.
yes,
Is there a difference when I noticed when I was typing out month or minus month underscore ABB, there was, I believe if I'm not mistaken, I saw there was one that said month dot ABB. Is there a difference in that? Anything significant on that?
so on my side, I don't think I have a month dot ABB. Perhaps.
I
on
may have been
your side-
mistaken.
Yeah, perhaps when you were coding on your side, you may have.
Yeah, so I see month dot ABB.
Yeah, I don't have a month dot ABB. Anyone else have that issue? I think it was probably where the place where I will look into it is where we created month ABB, which was. Let's see, that was before this, was right here. So the chunk for FE month, if you look on your outline. This is where we created month ABB. So potentially you put a dot there.
Oh,
That could
well,
be-
no, that's fine. It's just like, and everything's running fine. It's just like I'm saying, when it suggested that as one of like the ones, and everything's running fine. Like I say, I just didn't know if that was a month dot ABB was a thing, or I mean, like I say, everything's been running fine for me. I don't think I put month dot ABB yet. I just didn't know if that was a function already.
Okay, so as long as you're getting the same number of rows as I am, then if you did something different, it's not impacting your workflow. If you are getting a different number of rows, then we're gonna have to troubleshoot and see what happened. Because it could be.
Yes, I'm good.
Yeah, so a good place to check is this last chunk that we just did. If you print that object, you should have 698 rows. If you don't, then something happened. All right, so just to kind of quickly summarize what we've done up until now, or what happened up until here, right? So if you remember all the way from the beginning of the previous exercise, we started with a data frame that had 698 rows because we had one observation of cotton fiber strength for each one of the side years, and we had 698 side years. Now, when we downloaded data from Daymat, we basically multiplied that number of side years by 365 because we have weather data on a daily basis. Whenever you have data at two different scales, either spatial or temporal, especially temporal in this case, if we were to go back to the data set we started this exercise, we would have that like 250 some rows. We had the year, the site, the strength. Those are the most important ones. I'm going to focus on those. We had those three variables repeated 365 times for each site year, right? Because strength is not changing on every day of the year. It is one value you get for the whole year, right? Whereas weather data is changing in that case on a daily scale. So that is a mismatch between the scales, right? If you run a machine learning model with that data set, you could get critiques because your base is not like you have 365 measures of cotton strength for that side year. You just have one, but you're repeating that so many times because you're matching that with the weather data. So that could be a critique you get because you're basically just making up like cotton fiber strength data that you don't have and trying to match that with the weather that is on a different temporal scale. So we brought that data weather, we created the summarizing window of month, we then extracted the mean and the sum, and now for each side year, and then we pivoted those columns so we have the month information as part of the column. So now we go back to 698 rows because now we have just for each site, each year, I have only one number for strength and then one number for mean day length in January, and then one number for mean solar radiation January, and so on. Right, so now we go back to that because for each one of the side years, I have a summarized weather variable for a given window. And then that window, the levels of that window are also transformed into columns. So now we go back to that same number of rows. And if you look into that here, now we have 75 columns, right? So these are all the new features that we created. We started off with 7 weather variables. We left these snow water equivalent behind because, you know, the southern US, I don't think that would be a very important variable anyways. But so we kept 6 original weather variables, and now we basically engineered a total of 72. We have 75 here, but the first 3 are side year and fiber strength. So we engineered 72 new variables out of the original 6. Right, so this is feature engineering, is you creating variables that may be more related to what the crop is actually, or what your response variable is actually impacted by. In this case here, weather on a monthly basis, either the mean or the cumulative of that variable. All right, so we're getting towards the end here. We have another half an hour, which I think is going to be enough for us to finish this exercise and move on. So I do want to give you all 5-minute break if you need a restroom break. So we're going to start back again at 11 a.m. Let me start a timer here so you know. Hmm. So maybe let's have a seat and I can more easy. So, you know, let's go by steps here. So this one is already giving you problems. So I think what you see here, your month and month app are in Ace, meaning that your issue started on the chunk that we created those columns. So the chunk that created those columns was here. So I think somewhere, so if we just print a month. So the date character is wrong. Date character was here, yeah, so here. So we were doing was we're pasting the column here, and then with the separator, and then the column, you know, or year, day of the year. So here. Yeah, so now if you just run everything after this point again, you should make it full. Thanks, Steve. All right, so our timer is up. Let's get back to our exercise. All right, so what I wanted to do next here is, so we're basically done with the feature engineering side of things, but I do want us to explore this data again, right? So coming back to the point of always look at your data using plots, that's going to be a really useful way to understand what's going on. I do want to introduce you to a new, at least new to this class, package called ggridges. If you have used this in the past and you know what it is, well, I guess if you have not used it in the past and don't know what it is, it's basically a different way for us to create density plots that I think is going to be a really interesting way to export this type of data. So if you don't have yet, if have not used in the past, you may need to install it. I left you the code there for you to install. Just uncomment that line of code. Go ahead and install it. After you do install, either delete the installed packages or comment it off as well. And then make sure you load that package so we can use it. Okay, so what I want to do here is take one of these variables that we have and then create a density plot. So what I want you to kind of picture here is imagine that density plot we did before, but now on the y-axis, I want to have different months. So let's say I want to have a density plot for January, and then a density plot for February, a density plot for March, and so on, kind of stacked that way. This is what ggridges does. I think is one nice way to show distributions, you know, using not just the x-axis, but also making use of that y-axis of the geom density, and ggridges allows us to do that. All right, so let's get started. This was going to be a ggplot, so let's call ggplot. The data here is going to be equals to the one that we just finished creating, which is called fe underscore month underscore sum underscore white. That is the last version. Or actually, you know, sorry, let's just stay with the month sum for now. So the month sum still has, we still have a column for month here, then we need that for this plot. So let's just keep the fe month sum. If you give it a comma, let's call a yes. So the x-axis, what I want to do is just take one of these variables and make the plots. I want us to take the mean Tmax in Celsius. So that's going to be our x-axis variable. On the y, we want to have the month abbreviation. So the column is called month underscore ABB. And then we're going to do something here that for now, just come along with me. You're going to see the effect of that once we do run the whole code. So we're going to say fill equals to stat function called stat of x. So this is what you would want that to look like. Now, if you get outside of that ggplot, so the last parentheses there, just add a plus, hit return. We're going to call this function that is called geom underscore density underscore ridges underscore gradients. So it's a long function name. You can use a tab to autocomplete that for you. There are a couple of arguments I want to change here. The first one is called scale. I want to say scale equals to 3. Well, you know what? Let's not do that. Let's just run without the argument first, and then I'll show you why I'm changing these things, so you can understand that. If you just go ahead and run this, this is what we get. So it's a density plot on the x-axis for the mean Tmax for each one of the months on the y-axis. And it makes sense that as you go from January to August, the distribution of the max temperature increases and then it decreases back again. I want to make a few changes to this plot just to make it look nicer. So if we come here on the function then, on the geom density ridges gradient function, now let's say scale equals to 3. What that's going to do is basically just give those density plots more of a tight distribution. So they're going to be, I mean, they're still going to cover the actual data that they do cover, but they're going to look a little bit taller and kind of like overlap more. You can play around with that. It's it's personal preference.
Hey, Dr.
Also,
Bastos,
yes.
can you scroll back up for me? It says error and could not find function ggplot. I don't know if I didn't load the right packaging. I loaded both of those you just showed us, but
So ggplot should be as part of the tidyverse, but you can come here and say library ggplot2 in case you're having that issue. That
yes, sir.
may fix it.
Thank you.
All right, another thing I want to change here is you notice how it kind of looks at the distribution from the lowest to highest across all months. And then for each individual month, it creates these long tails here. And that distribution is really not there for that specific month. So there's a way we can inhibit that. If you come to the geom density ridges gradient function, it has an argument for relative, so rel min height is the name of the argument. You're just going to specify what is the minimum height that's going to draw on the plot. I want to set that to 0.01. So rel underscore min underscore height. Oops, did I misspell this?
Yeah.
Height. Yeah. So then it kind of like cuts those tails for us. The next thing I want to do here is change the color or the fill scale. So we're changing the fill, right? So this blue here is the fill. I don't know if you can see, but it has a gradient inside the density plot, which I think is pretty cool. But with the blue color scale here, it's not very evident. So I want to change that by coming to the plots. I want to call scale underscore fill underscore varieties underscore C for continuous. And I want to change that to option equals uppercase C. So varieties scale has options going from A through G, I think. I want to change it to C because it's going to give more of a temperature look to it. This is how that looks like. And then lastly, really here, this legend is the legend for the fill, right? But we really don't need it because it's just giving an extra visual aspect, but we really don't need these to be here because we have those values on the x-axis. So I just want to remove that axis, the legend. So we add a plus, we call the function theme. It has an argument called legend dot position, that if you set to none, it basically removes the legend for us. And this is how it should look like. Let me just show you the code in case you are you want to catch up, and this is how that will look like. So anytime that you want to show the distribution of something by a group, in our case, that group is month. But if you wanted to show by site or by year, or maybe by block, by treatment, you could have that, use that along with this ggridges approach. And I think it's a very appealing way of showing this. All right. So now my goal next is to do the same thing, but for all the weather variables. Right? So again, we're going to be using some of the automation iteration skills that we learned a couple classes ago. I want to make the same plot, but for all of the other weather variables. So if you come here to the next chunk, I left that the name of the object I want to have this is final plots. So let's just give this assignment symbol. This point, we're going to start off with the FE month sum as well. So this, if you remember, FE month sum is the one that we still have a column for the month. We don't have yet the months on the column names. And for this plotting purposes, that's what we need. It's not the one we're going to be exporting, but for plotting purposes is what we need. Okay, so let's think about this. I want to make a ggplot where each plot is going to be the same as the above, but for a different weather variable. There are a few things we have to do to get there. What would be the immediate next step to do it? If I just print FE month sum. So we have to pivot longer, right? So here's how I would think about this. In ggplot, I know I want to use facet. Every time you think I want to make the same plot, but for different levels of a column, that the answer for that is always going to be facet if you're thinking about ggplot. So we want to facet. For us to facet, we have to have a column where I have the levels of what I want to facet over. Meaning I have to have a column here that says the different names of the weather variables. Right now, if we look at the current data, we do not have that, right? The column, the weather variables are still in their own columns. So that is what prompts you to think I need a pivot longer in this case, right? So let's go ahead and call pivot longer. The columns again are going to be from mean day length dot s colon to sum underscore prcp dot mm. So if we do this and we print final plots, now we have a column called name where all the variable names are under, and then a column called value that has their values. Okay. However, there is a little bit of a difference here. That if we could put this right through a ggplot and do a facet by name, it would work. And actually, let me do this on my side, just so you see what happens. You don't have to do on your side because we're going to delete this in a second. So if I just copy that code, just plug that right here, what I have to change, so our X values are now called value. And I have to have a facet function for this to work properly. So let's do facet wrap by name scales equals to 3. Okay, did not like something that I did. Should be created with a yes. Oh, yes. Thank you, Pramod. Yeah. Okay, so this is how that would look like if we just put right into a ggplot. What happens here is because our day length in seconds has such a wide range or a large range of maximum values, and when we're doing a facet, you're keeping the same, in this case, fill legend for all plots. So really, we don't get a gradient for any of the other plots because they're always skewed in the color scheme of day length. So this is what happens so we could do this if we were not coloring or filling the densities by the value, we just had them as empty or just a fixed value. this would work just fine. But for the effect that I wanna do here, having that fill of the density changing in color as well, I want that fill to be able to change individually for each one of these plots and not be bounded by the range of values of one of them. Right, so this is the problem, I guess, in this case. Let's see, someone had a comment here. Data, yes, thanks, Ikar. So for us to fix this problem, we're not gonna use faster rep. So I'm just gonna come right after that and just delete this whole thing for now. What we are gonna have to do is create a separate plot for each one of those variables individually. So they are allowed to have a color scale that is specific to that plot. We're still gonna use ggplot. We're not gonna use facets though. How can we automate that? How can we make that process work? Map, right? We're gonna use map here. All right, so, well, first, before we use map, we have to specify the grouping. I see somebody had a comment. Yes, mapping, that's it, Gonzalo. So we need to specify that grouping and then nest. That's the first thing we have to do here. So I'm gonna group, oops. I'm gonna group by name, which is the current column that has all the weather variables names under. And then I wanna plug that into a nest. So when we do that, remember that when we nest, it basically takes all the values that belong to that grouping variable and kind of shoves them into a data frame and put that into a cell in this column that now is called data. So this table here is a full data frame in one cell, right? We've already seen this, so I'm not gonna get too much into that detail. But now that we have that data nested, we can add a pipe, call a mutate. I wanna call this new column as plot. And I do want to use map too, because I want to give the data, but also the name, so we can have this name updated on the label, on the x-axis label of the ggplot. So we just call plot, let's call this map2, where the first thing that we are going to give it is a data. The second argument is going to be the name. Give it a comma. Let's just hit return a couple times to break code. Let's give it a tilde. Remember with map and map2, when we start the function, we give a tilde so we know we're starting the function. And then you can just come here on the previous chunk and copy all that. And we're gonna paste right after that tilde. We're gonna have to change a couple things here. One of them is the data. Right? So now we're using the map function, map2 in this case. So the data is going to be that argument that we give first, or I mean, it could be the second one. I guess the order doesn't matter, but it's going to be one of those two arguments. So we're going to delete the FE month sum. Now, how do I specify the data inside of map2? .x, right? So .x is going to specify that that data should fit right here. Another difference here is that on this data frame, I don't have the mean Tmax C column anymore. I have a value column, right? Because we did the pivot longer. So change that X equals to value. And then one last thing we want to add here right after that theme. So if you go after this theme here, add a plus. I just want to say labs. So I want to change some labels here, where the x-axis label is going to be equal to .y. And .y is the name of the column that I'm making a plot of through the map. So just to recap, we basically copied and pasted the code from above. We changed the data argument to .x. We changed the x value on the AES to value. That's the name of the column inside of that data frame. And then we added this plus labs x equals .y. And that's it. So now if we just go ahead and run this, if you got all of your commas and parentheses right, it should have worked. If it didn't, I can help you at the end of the class. But it did work on my side. So if we now print final plots, we have this column here that is called plot because that's the name we gave it. where each object is a ggplot object. So now we have, 6 different plots that we just created iteratively using map2. And then I just want to see those plots. So if you come here on the next chunk, it's just going to be printing that plot column, which is going to print each individual plot for us. And then we can just select from the list and visualize them with having a variable specific fill here, right? So the fill is not being affected by different variables. They have a fill that's specific to that variable. So we can see that distribution over different months for different variables and have that fill follow along as well. Okay, so this is just, I wanted to show you another way of a very, professional looking, intuitive way of looking at this distribution over time, over different months. Now, the last thing I think I left in the code there was just for us to export this to file. Now, when we are exporting, we're using the latest version that we wrangled, which is the FE month sum white, which is the one that if you just print that below, that has 698 rows, and each month by weather, by summary variable is its own variable, right? So the month information is on the heading and not in the body. So we're just exporting that as a CSV file that we're naming weather month sum, just exporting that to file. So make sure you run this because the next step, we're going to be using that data set. So we need to have that created on your side for us to move forward in the next steps. All right, so a very quick summary here. So today we imported the original 7 weather variables that we got from Daymat. They were on a daily scale. We feature engineer a total of 72 new variables based on those original variables that use a monthly window size and a summarizing function of either mean or sum. We looked at the distribution of those data, those new features above, and then exported that to file so we can use in future exercises. Let's see. Question here. I was having an issue. If you could help me for a quick second after. Yeah, I can connect with you, Austin. We can connect after class. All right. Any questions or thoughts about what we're doing? Okay. I don't hear anything. So I do want to take the next 10 minutes or 9 minutes to tell you about the midterm projects. I was finally able to get to it. So I pushed to GitHub. So whenever you did do a Git pull this morning, you probably already got the files that I had for the project as well. Let me open that on my side. So the folder is called 06 midterm project. It has an Excel file with the group assignments. If you open that, you're gonna find, so students that had a project are on this column, students without a project are on the second column, and the groups are in the row, right? So group 1 here is Jazib and Ujwal, for example. So you guys are gonna work together. If you did not have anyone assigned to you, is because we did not have enough students without a project to assign to everyone. So Chris and Sekar, that's why you don't have anyone assigned to you. And I was trying to match people that had, like people that did not have a project, assign you to a person that had a similar enough project that you could learn from. But maybe that wasn't a perfect match, but I try my best to do that. So we have a total of 10 groups. So if you're alone or if you're in a group, you're going to submit 1 project back to me. I have here a QMD file that I sent along as well that I shared in there as well. Let's see if that. Okay. So this, let me walk you through here. So this script here, if you're alone, just write your name here. If you are working with someone else, we'll write both names here on the top of the author. Once you go through the steps that I'm giving on the instructions, I want you, oh wow, that was too much. I want you to paste right here the URL of your GitHub repo that you're working with this. So the goal of this midterm project first is to give you the chance of running your own data based on what we learned, and also to collaborate with someone else through GitHub, right? So those are the two main goals I'm going to be looking for here. The instructions I have for you is, well, first we'll scan through these instructions kind of quick, but I do want you to go back and read them again, because it's important that you follow them. So this file here has both the instructions and also can be used as the script that you develop for the project. So we don't have to create a new script if you don't want to. You can just use this one. Every time you create a plot or a table, I want you to first, before that chunk, that you tell me what you're going to do next. Give me some details of what you're thinking. And after you see the output, especially if it is like a summarizing table or maybe a plot of any sort, I do want you to write below it some interpretation of what you're seeing. Not just, if you just give me a plot and move on, you're not going to get full points for that. All right, so if you're working with someone else, this is how I am proposing that you set up. So student number 1 in the list is the one that has the actual data, that has the projects. So that student is going to go on their GitHub and create a repository where you can be named something like this: 2024 DSA mid project group X, where X is your number on that Excel file. So this is your group number. That's what I want you to name your repository. I want it to make public, add a README, add a git ignore for R. Now, student 2 is going to follow the same steps as we did in class to start a new RStudio project, right? So everything we did in class, we have instructions for that in a different lecture set or slide set, in case you need to refer back to that. But basically, the process of you connecting that GitHub with your local machine. After you do that, you're going to create that subfolders code data and output and move this script here inside of the code folder, and then move your data that you're going to be working with from your project inside of the data folder. So really the workflow we've been doing up until this point. And then on GitHub, that student that created the repository is going to go to the settings and invite their partner to be a collaborator in that repo. The partner is going to get an email from GitHub saying you were invited to collaborate on this project. You accept that. And then at that point, you can do a clone. You can clone that repo to your computer, and then you have pull and push rights to that repo. So once both students have this clone on their personal computers and laptops, then you can start working together on this. I do want you to update your README. So remember, the README file is the one that shows up on your GitHub repo when you open it. I want you to give a description of what that is, who is working, what is the purpose of that GitHub repo. So I wanted this to be very professional. I want you to be paying attention to those details. All right, so my goal here is that so especially for student 1 is going to have to do more work than student 2 regardless, because student 1 is the one that knows the study, knows data collection, knows how to explain about that. So there's nothing student 2 can do about that. That's going to have to come from student 1. So I want the student 1 to give me a little introduction here. It does not have to be like a full-length paper introduction. It's just 1 or 2 paragraphs to tell me, as if you were like a shortened version of an intro of a paper, right? Why are you doing this? Why is this important? Why are you collecting this data? Then I want you to very clearly define your hypotheses and objectives. Remember, your hypothesis, as we talk about in class, right? Your hypotheses have to be testable. If you use words that make it either or, not testable, right? You have to be bold. You have to say this treatment will increase yield, and if it doesn't in the end, oh well, your hypothesis was not fulfilled, I guess. But hypotheses need to be bold, and then tell me your objectives. I want to be able to read your objectives, and already just from reading your objectives, I want to be able to already picture what plots you're going to show, what analysis you're doing. So if you tell me here you want to assess the effect of, I don't know, variety on yield, and then for some reason you show me a regression analysis, those are not matching, right? You kind of have to think about objectives that are very clear and how they connect to your analysis later. I want you to provide me some information about your material methods. This is mostly so I understand how data was collected, but also how it was planned. I want to be able to understand if I'm reading a paper and I want to understand if they ran the proper analysis for me to even trust what they're saying, I go to material methods and I read. Is this the design they use? Is the analysis that they're giving me here connected to that design? So I want you to give me enough information for me to understand, are they running the proper analysis here? Then study design, again, you're going to go, I give you some information here, but you're going to tell me about what was your treatment design, what were the factors, the levels, what was your experimental design, how were things randomized, and so on. And then lastly, you're going to explain to me your statistical analysis, right? So I want you to tell me, like, we ran a mixed effect model analysis of variance with treatment, whatever that was, as fixed effect, with blocks as random, or was a split plot, or was a repeated measure, whatever it was. I want you to describe those to me in a way that if I'm reading this, and if I had your data, just by reading this, I could write your code, the code for this analysis myself, because I know exactly how it treated things, what function it used, what package you use, and so on. So making this reproducible in words, I guess. And then under results is really where you're going to show me all of your workflow, right? So you're going to bring in data, load packages, whatever is your analysis itself, you're going to explain to me, or not only explain, but run the actual codes, create the chunks, write the interpretations for every workflow that we had. So if you remember, all workflows we did involve bringing in data, doing EDA, wrangling data, running a model, checking model assumptions, extracting something out of that model, let's say the means, making a publication ready plot. So that overall workflow we did for everything. That's what I want to see here. And it's going to be up to you of what you're going to show me, because it's going to depend on your own analysis. So this is going to be up to you. And this is really perhaps where student 2 comes more into play, right? So I would imagine that those of you that do have a project, you may already have done most of this already on your research for presentations, papers, whatever it is. If that's the case, that's fine. But I do want to ask you to talk with student 2 and gather input, because perhaps when you did this, if you did this before this class, maybe you did it in a different way, or maybe you made some mistakes that you're not even aware, and maybe your partner can help you. Like, why did you treat this as random or fixed, or why did you extract this name from that ANOVA table, whatever it was? So do talk to that person. I want you to be talking. I do not want student 1 to say, here's the project, just sign your name. That is not the goal, right? I want student 2 to be involved, give feedback, give suggestions, work on the code as well. So something you can do, for example, is, let's say student 1 is going to provide the data, and you can have a chat with student 2 and say, hey, do you want to get started with the wrangling side? And then, that person works for a little bit. It's not a lot of work to do that, but just starting with that. And then student 2 comes in, and student 1 comes back and says, yeah, that's a good point. Maybe we need to make this as a factor, or, so you work together on that. Does not have to be sitting in the same room. You can be just doing this through GitHub, through, email, whatever. But I do want you to be working together and making decisions together. All right, let's see. So yeah, I want you to describe what you're doing before the chunk and also give me an interpretation of what you're seeing after the chunk. I guess it will depend on how much time I'm going to have to do all this when the grading comes. But if I get to the point where I think I want to spend a little bit of time and see how many commits each student did, I can do that because your GitHub repos are going to be public. So again, make sure you're working together. And again, the first part is probably going to be led by student 1 because it's their project, but the student 2 should be working as well, especially when it comes to the beginning of the analysis and bringing in the data and so on. If the data is from an unpublished research work, is there anything we have to concern about the privacy in the GitHub repository? Just being curious. That's a great point, Sekar. So yeah, so maybe let me adapt what I'm saying here. So that's a good point. So if you do not feel comfortable sharing your personal or your research data now on GitHub, that is a very valid concern. If you do not feel comfortable and you do want to make your repos private, you can do that. I only ask that then you also invite me as a collaborator so I can see it. If you do want to make it private, you're good to do that. Just make sure you invite me as well, so I have access to that. All right, so we're going a little bit over time, but I do want to finish this so you all can get started on this as soon as possible. So one tip here is that whenever you're working with someone in a programming project through version control, you may have merge conflicts, which I would try my best to avoid having a merge conflict, because that's going to be the easiest, is not to have it in the first place. If you do have it, I can try to help you with that. But really, this happens when two people are working on the same file, on the same place of the file, and make different things and then push, right? So GitHub says, well, I already have something else on this file, this row here. What should I do? So to avoid that, perhaps you can say, you know, I don't know, you can try to coordinate, like maybe this morning, one of you works, then you stage, commit, and push. And then before the next student works on it, does a git pull, already gets all those changes, works on it, commits, stage commits, push. You know, so kind of like almost taking turns on whenever one or the other works on it. That would help you to avoid merge conflicts. But if they happen, we can fix them. Something else I use sometimes is I use the issues tab on my repos as a to-do list. So as you have, let me just quickly open here a GitHub repo for you to see. So just to let you know, if you do have to leave, this is being recorded. Just send me an email if you had to leave before I took attendance. But I just want to show you here. So I'm going to show you a repo that I was working with a student on an analysis where it's just myself and this student. So if you come on issues, we were having issues as to-do lists. And when you do create an issue, you can even say, like, I don't know, Wrangle data. And then you can give a description here and you can assign this to someone. It could be to yourself or it could be to another. Does that help? It could be to yourself or to your collaborator. You can assign that to someone and have as a to-do list. So let's say you get here, you have this to-do list assigned to someone, and then the person runs into an issue. They can come here and say, hey, I was doing this, I had this question, what do you think? You can kind of have issues as a to-do list and also a forum for you to talk about decisions you make. All right, so when you are finished and ready to submit your work, I do want you to render this to HTML and send me the HTML. Your HTML is going to have in it, in the first line, the link to your GitHub repo. So I can also bring that and look into if I have questions or if I'm unsure of how things were done. I have a whole bunch of notes on rendering. I'm not going to go through them one by one, but the bottom line I want to tell you is this output should be professional. This is a graduate level course, and I do not expect you to turn in an assignment that does not look professional. So if you render it and it does not look professional for whatever reason, I want you to fix that before you send it to me. Otherwise, you're going to lose points for lack of professionalism. One example, for example, is if you print a data frame that has a million rows, I do not want to have to scroll through a million rows, right? That's not helpful. Rather than doing that, you can just use the function head and show me just the first 6 rows of that data set, which is really what I need to see, right? So things like that, like you want to make it professional and tidy and not be confusing. And then you have 2 weeks to work on this. So it's going to be due on April 11th at 11:59 p.m. You can send me your render HTML with your answers. If you do have questions or issues, please use our 2024 DSA GitHub repo to ask questions there, especially if those questions can be applicable to other people, right? If you have a question very specific to your project, then maybe you can create an issue in your repo that you're working with and just tag me there. I have a question, tag me there. I can come in there, help you out. If we need to, I can connect by Zoom, I can help you out. My goal is that you use this opportunity to apply something that we learn in class to your own data. So this is what my goal is. Maybe your data is nothing, it has nothing to do with the things that we went in class. In that case, I will try my best to provide you with resources that you can explore and maybe run the best possible model for your case. If your case is really massive data and it's gonna take a whole semester to fix that, then, you know, we can compromise and just do the best we can at that point. But that's a conversation that we can have on a one-to-one basis if needed. All right, any questions? Lots of questions. Okay, so I'm gonna just take attendance here. All right, I just opened the issue, make sure you claim your attendance. And that's it from my side. So if you have any questions, let me know. And otherwise, I'll see you next Tuesday.
Hey, Dr. Bastos, could we talk for a second about my issues I was having?
Yeah, so maybe let's do this. Let me go to my office and then we can connect just one-on-one. So
Yes, sir.
if you can send me a Zoom link, I'll connect shortly.
Yes, sir. All right, see you in a couple minutes.